Okay, we finished the full sample analysis for binary outcome. Now we are going to restrict our sample to a subgroup. By the way, before coding, you have to understand what you are going to do the next step. So we are going to use, we used full sample, and then we are going to use a subsample, and then in the next step, we are going to use the full sample again. Then a typical mistake here is if you delete some observations to use the subsample analysis to do the subsample analysis, then the problem here is if you delete something, you have to recover them for the next step. So you should be careful when you delete. Don't forget to save the original file as a separate file so that later you can load the original full sample again. So typical mistake is just delete and save everything, then you have to re-download the data file again. So there are many other ways, different techniques to use to restrict your analysis to subsample. But let me show you what I'm going to show you here is I will delete some observations and save the data as another file so that the original data file is not changed, right? So let's do that. Remember, we are going to restrict the sample to college graduate, non-white, 30 years or older. So we will keep college graduate and we will delete white, and we will keep 30 years or older. So three conditions. Here, sample restriction. So we are going to so remember, first college graduates, keep if college graduate equals to 1. Look at this, call grad, this variable equals to 1 if the mother has college degree. So we will keep the observations if college grad equal to 1. By the way, again, remember, we are using double equalities because it is a condition. You are going to keep if that condition is satisfied. So this is not a definition, but a condition. And then second, drop if we are restricting our sample to non-white, so white. If white is 1, we are going to drop. So white mother equals to 1, then we drop that observation. So keep and drop are exactly the opposite. So if the condition is satisfied, you drop that. If the condition is satisfied, you keep that, and all the others are deleted, right? And finally, keep if age mother equals to 30 or greater, right? So these three conditions are what we are going to use in our subsample analysis, right? And again, this is so what you have to do here is you have to save the data file as another, say, subsample. I'm going to use this command to save the data after this manipulation. So when you drop some observations, I'm going to save the file as a different file so that the original file is untouched. So run this. Then you are going to have subsample data. Currently now you are using the subsample, or you have already deleted the subsample. Later we are going to use this again. So later when we need subsample, then we are going to load this data again. Okay, now this is what we have done, and we are going to repeat everything we have done earlier. So it's very simple. There is no difference. I copied the same commands I used earlier for the full sample, and I repeated them, pasted it again. However, the problem here is like white M is deleted. So you don't need like let's see. By the way, I predict there must be some problem with white M because we have deleted white. Also, there must be some problem with these guys because we deleted high school grads and some college and everyone who does not have college degree. So there may be problems, but Stata will automatically fix that. Let's see what we can do. So I'm going to drag. I'm selecting this part and run. Then let's see. Automatically the Stata understands and omit those variables. Those variables cannot be calculated in the restricted sample. So the restricted sample starts from here. The mean is now 71%. 71.86% of mothers in the restricted sample are working. So higher probability of working than before, than full sample. And the effect of kid count in the linear regression, the effect of kid count on mother's working status is smaller, 6%. Only 6% decreases. Previously, it was about 11%, but now it's 6% point. And Probin model is calculated, but again, you get something, but it doesn't mean anything. It means nothing. You don't need to bother to interpret this. Has no meaning, but you can look at this. So the effect of marginal effect of kid count on mothers working is again 6 point something, 6% point. So the same analysis will give you these numbers. So when you make a table, you have to make a table like this, and these 3 points are. By the way, in the parentheses, you have to use the standard deviations, standard errors, calculated next to the coefficient. So copy those numbers from your result. Okay, then we filled in like half of the, a quarter of the analysis. Okay, and in the next step, we are now changing our dependent variable. Now the dependent variable is not working status, but hours worked. So remember, it is a censored variable. We will use the censored variable with full sample. So let me show you how we load the original data. So we are changing our model. And the first step we have to do here is we have to use this original data file again. And you have to put replace option. So putting replace is not bad. Like I'm going to put replace here. So just replace means just replace and the existing data. So before doing that, now excuse me, in the restricted sample, the number of observations is 2700, and if you reuse the original data, it was, what's this, 242,000 observations. So we recovered our original full sample, so we are going to start analysis from here. And before doing the analysis, let me make a scatter plot again as before. Disable. I'm going to create a new scatter plot for hours. Where is hours? Hours and kid count. Accept. Okay. This is the graph. This is the graph. And again, the scatter plot. Scatter plot is hard to interpret, but it's better than before. Like first, the problem is it's 0 to positive. But I don't know how many observations are accumulated at 0 point. 0 must have a lot of observations than like 100 hours per week. So there may be a small number of observations here. Of course, imagine like how many mothers work 100 hours a week. But on the other hand, there must be much more observations here, but that cannot be distinguished from the data, from the scatter plot. From the scatter plot, it looks like people like mothers are distributed quite uniformly across here, but actually not. There are much more. There must be much more observations here, and this is a censoring point. Minimum is 0. Cannot go below than that. So 0, 0, 0, 0. And also it looks like just 1 point and 1 point, but of course there must be just one or very few mothers here, and most of the mothers must be here. Imagine these mothers have 12 kids, and then would it be equal? Of course not. And so the scatter plot is not the best way to see the pattern in this case again. But still, it's better because you see some kind of downward sloping trend. It's pretty clear. The trend is going down, but it's not easy to see how that trend, where you can draw the trend line. We are going to do that in the next video.